Thank you for joining today's session. So for today's session, we'll be discussing about how to deploy self-managed nodes within OKE, which is a new feature actually that we've released. So a little bit about myself. My name is Desmond, Desmond Muriu, and I'm part of the OCI domain specialist team focusing on compute services. So before we head over to the demo session, where I'll actually show you how to add an existing compute instance, which is what we are referring to as self-managed nodes within OKE, I would like just to have a brief session to discuss about what are the different type of nodes that we have within OCI, what do we support, and what kind of use cases do each of the nodes apply to. So what you do within OCI is that depending on the kind of agility you want, or rather, from the other end, the kind of control you want, we have a different node type for your use case. So we have what you call the virtual nodes. So the virtual nodes give you like a serverless architecture where you, as the end user, you don't get to manage any infrastructure. The beauty about this is that it reduces the burden you have from your end, but of course from the other end that you have less control of your infrastructure. And then on the far right, you have what you call the self-managed nodes, which is what we'll be discussing today. This is the new service that allows you to add a compute service, which is what you've actually created within our compute service, within our compute services. And now you can be able to bring this service into an existing OKE cluster and add it as a worker node. And regardless of the node type that you take within Oracle Container Engine, or rather what you call OKE, the control panel, or rather what you call the master node, will always be managed by Oracle, regardless of what you choose to do with the worker nodes. The control panel will always be managed by Oracle. If you want to manage the control panel for yourself, or rather what you call the master node, with that one you might want to maybe look into how to create, how to do it yourself, how rather to do it yourself Kubernetes cluster within OCI. So just a bit more focus on the node types. So with the first option, what you call the virtual nodes, so here we get to see there's what Oracle manages, and then there's what you as the customer manages. So with the control panel, like I've mentioned, regardless of the use case, regardless of the node type that you choose within OKE, to be specific, the control plane is always managed by Oracle. With the virtual node, to be specific, now we also manage the infrastructure of the worker nodes. And you as the end user, rather you as the customer, you only get to manage the applications and the services that you deploy within, or rather on top of your OKE infrastructure. So the reason why you would want to use this is that, of course, it reduces operational burden. You won't be the person managing any bit of infrastructure from the worker nodes and also from the control plane. You get a complete serverless experience. And of course, due to the limited control from your end user, there's also limited we also limit what you call the human error burden that could exist within your infrastructure. So because you've automated everything from your end, it means it will become more secure from your end. Of course, also for cost optimization, it will be the best guaranteed. But as of now, just to note, the virtual nodes, as of the point of this recording, the OKE virtual nodes, they still don't support persistent storage within OKE. If you want to use persistent storage, you might have to plug in, or rather to embed your solution into one of our database services, or maybe also use our object storage service. So the other option is the OKE managed nodes. This is what maybe if you've interacted with OKE before, you might be familiar with the managed nodes. So with the managed nodes, we've had this. This is what we've been having for the longest time since we deployed, rather, since we had the OKE service within OCI. And with the managed nodes, what happens that within the worker nodes, we have what we call shared responsibility model when it comes to the upgrades, the resource scaling, and the resource management. So there's bit that Oracle does, and also this is the bit that you as the end user does. And of course, when it comes to the application and the services that you deploy, this is entirely managed by you as the end user. So this kind of a service or rather feature is suitable for any kind of stateless or stateful feature. For example, if you find that maybe the compute shape you want to use isn't supported by our managed node service, this is then whereby you might find yourself going for our self-managed nodes. So with our self-managed nodes, like I mentioned at the beginning of this presentation, is that it gives you the ability to add a compute instance that you've already created within an existing OKE cluster. So what it means is that, for example, if you want to use our RDMA feature, our part of our HPC offering, you've created an HPC cluster that uses the RDMA network, and you would like to utilize this infrastructure within your OKE service, you can be able to bring those compute nodes into an existing OKE cluster. So it's suitable in situation where you want to do advanced configuration, or maybe you want to use a shape that we still don't support within our managed node service or our virtual node service. The other option, of course, is where you do everything yourself. So in this case, you just create the compute nodes, install the Kubernetes software within this, and you'll be the person to manage the entire architecture, including the Kubernetes infrastructure that you've installed within them. The reason why you will find yourself that you need to do this is because maybe the version that we currently have within our OKE service is not the version that you want to use. Maybe you want to use a later version, or maybe you want to use an operating system that we still don't support within OKE. This might be one of the means to go and to ideally achieve this kind of a scenario. So remember, with this kind of a situation, the control plane, the worker nodes, all of that is managed by you as the end user. So everything is entirely falls upon you. So if you want to do any upgrades, if you want to do any scaling, all of this is managed by you as the end user. So just as a summary, the different types of options that you have when it comes to Kubernetes deployment with OCI is, one, you can do it yourself Kubernetes. This is where you create the Kubernetes, or rather you create the virtual machines or the bare metal or the GPUs, and then install the Kubernetes software within there, and you'll be the person to manage the entire architecture from the bottom all the way to the top. And then when you go to our OKE service, the control plane, or rather what you would call the master node, this one is managed by Oracle on your behalf, regardless of the type of worker nodes you go with. And now for the worker nodes, or rather what we call the data plane within OCI, you have different options. So this is what we've been discussing about. So you have the virtual nodes. This is a completely serverless architecture. You don't get to have direct access to the actual compute resources that are running the worker nodes, similar to the managed to the control plane. You only get to manage your service and your application that you deploy within the Kubernetes service. And then, of course, for the managed nodes, you have some form of a kind of a shared responsibility model where some bit is managed by Oracle and some bit is managed by you when it comes to resource management, scaling, and the likes. And then with the self-managed nodes, this is where now you bring your own compute service that you've created. within an existing OKE cluster. So here still, we as Oracle are managing the master node, or rather what you will call the control plane, and you have complete control and complete access to your worker nodes, and you'll be the person to manage it from any form of upgrades, any form of scaling and resource management. All of that is ideally under your control. And like I mentioned, the reason why you will go with the self-managed nodes is maybe because the specific shape that you want to use, it could be you want to utilize our HPC infrastructure or RDMA networks. If it's still not supported within the OKE service, this is one of the way you would go about to using this compute service within an existing OKE cluster. So with that, what we'll do is that we'll go into a demo session, and in this demo session, I want to showcase how to add a compute service, or rather a self-managed node within a Kubernetes, or rather an OKE cluster. So with that, we'll head over to my compute console, rather my OCI console. Just maximize my screen a bit. And for you to access our Kubernetes service, if you've not yet deployed our Kubernetes service, how you go about is that you click on the top left, the hamburger button on the top left, go to Developer Services, click on Kubernetes Cluster OKE. And within here, always make sure you're in the right compartment, and then click on Create Cluster. So for this session, I won't focus on how to create a cluster. We've had different presentations before about how to create a cluster. Just go have a look at that, and you will get the experience within it. Just something to note is that for you to use the self-managed nodes, as of now, it doesn't support the OCI VCN pod native networking. So you'll have to use the Flannel overlay for you to utilize the self-managed node feature within OCI. So the prerequisites for us to add a self-managed nodes within a Kubernetes cluster. For example, I have already created a Kubernetes cluster over here. I need to create a dynamic group, and this dynamic group, I address it to my specific compartment, and then I need to give this dynamic group the correct policy to allow it to be able to join an existing cluster. So how you do this is that for us to create a dynamic group, just go to Identity and Security, have Domains, click the specific domain that you want to create the dynamic group in, and then within here, just click on Dynamic Groups. So I have already created the dynamic group. And ideally, what you just do, you give it a name. So for example, with my dynamic group, I've called it OKE self-managed node. And within this node, I've said that I want all the instances within my compartment to belong to this dynamic group. So how you define that is that there's a policy here that says all. Then I give the instance because I want them to be of type compute instance. And then I give the ID of my compartment. If you're not sure about how to achieve, or rather how to get the OCID of your of your compartment, your specific compartment, how you go about is that you just go back to Identity. Let me open that in a new tab. Click Compartments. Then you'll have a list of all your compartments. And then within a specific compartment, there is the information of this OCID. So you just copy that and add it to your policy. Now, once you've made sure that your dynamic group is okay and that you've created the right policy, now we can go ahead ideally we can go ahead. Now that we've created the dynamic group, now we need to go ahead and define the right policy for this dynamic group. And how you do this, that is, you simply just go back to the identity page, click on policies, and then create a policy. So in this policy, ideally, it's simple. You just define that you want to allow this dynamic group. So let me call it OCI self-managed nodes policy. Give it a description, just say policy to allow compute instances to join a cluster. Click on a manual editor, then paste the policy. So how the policy will look like is that it says allow the dynamic group. The dynamic group, you give it the name that we had created before, and the domain. So you start with the domain and then the name of the OKE class, the name of the dynamic group, which is OKE self-managed node DG. And then you say you want to allow it to join a compartment called demo. So depending on how you, with your scenario, you just need to make sure that the dynamic group name is okay. Let me just maximize this a bit. The dynamic group is okay, and also make sure that the compartment name, you're using the correct compartment name depending with your situation. And once you've done that, I've already created this policy before, so there's no need to add it again. I just click on cancel. And then now I can go ahead and launch a compute instance. Now, for us to create the compute instance, just click on the top left hamburger button, click compute, then click instances. Make sure you're in the right compartment. So for example, already this compartment, I have the 3 worker nodes that were already existing within my cluster. These ones are the managed worker nodes. But now what I want to do is that I want to add a self-managed node. So for example, just a bit to give essence of what I'm trying to explain, let me just access this cluster. So if I click on my cluster, let me access this cluster. So I launch Cloud Shell. And OCI will give you the ability, or rather it will pre-build the commands that you need to use for you to access this cluster. So I'll just copy this within my shell. Enter. So now if I do kubectl get nodes, this is visible, I'll be able to see the existing clusters, the existing worker nodes that exist within my my infrastructure. So these worker nodes are the same ones that are already existing within my instance page. So they're just these 3, or rather these 4, instances, and I can already be able to see them within. If I just write kubectl get nodes, I'm able to see them within my Kubernetes infrastructure. So what happens is that 3 of these are managed worker nodes, and then 1 of them I had just previously installed it as a self-managed node. So in this case, we want to add now a 5th self-managed, a 5th node, which will be of type self-managed node. And how we do this, that we go back again, minimize this, click on compute instances, make sure you're in the right compartment by checking on the bottom left. Remember the policy that we created was specific to the demo compartment. So if I was to use or rather to create this compute instance in a different compartment, I may not be able to join it to my existing cluster because I don't have existing policies for that other compartment. So for this one, we are still using the correct compartment, which is the demo compartment. So now just what I need to do is come on, create an instance, call it instance self-manage, just for purposes of demonstration. It's in the correct compartment. Then choose the placement. So the placement in this one is ideally I want to choose the availability domain. I'll just leave it as default. Now, something you need to note and be very careful about is on choosing the image. So for the image right now, you only have you need to use an OKE image. And how you'll be able to find our OKE image is that we have a publicly available site where we have all the OCIDs of all the images. So you just come over here and search OKE and it will give you a list of all the OKE images that we currently support. So what you need to do is that you need to come and select the image of your existing region. So for example, in my instance, let me just do this again. In my instance, I'm using the Frankfurt region at the moment. So I need to come over here and get the OCID of Frankfurt. So for the OCID of Frankfurt, just select it here. Here it is. Control-C. Come here, change images, and for us to add the OCID of the image, you need to select My Images, then select Image OCID, and then copy paste it. Just copy paste it again. Once you're done with that and everything is okay, select Image. After that, you can just select the shape you want to use. Keep it as default, the E4. You can use dual CPUs, select shape. And then now I need to give it information about my network. So I already have an existing network. I'll just utilize it. And select the subnet for this specific VCN. So I want to use a private subnet for my nodes. I can now upload my SSH keys so that anytime I want to log into my infrastructure, this is what I'll use. And once you've done that, now we need to do the last part, which is create a cloud init script file. So for us to do this, on our public documentation, we have a template of how to use it. So let me just copy it as it is. So if you see this script, we need to give some endpoints. So within the image that we selected on top there, there's already a pre-built script. And this pre-built script, you need to give it some few parameters. One is the API server endpoint. And how you get this is that you just go back to your cluster information from developer services, Kubernetes cluster. So within this cluster, I'll be able to see the API private endpoint. So I'll just copy this and paste it within this initialization script. And then make sure you don't include the port number. And then for us to get the Kubernetes certification, we need to go back again to our cluster and then write a command of how to access it. So just paste this command. to give me my certificate, copy it, and paste it within here. So once you confirm that everything is okay, key points to note is that, remember, always make sure that the dynamic group and the policies are okay. Second thing is to confirm that you're using the correct image, and how you find that is that within our public page, you can be able to find the correct OKE images that we currently support. So make sure to copy the image of CID. And then last but not least is to include the initialization, the cloud initialization script, and modify it based on your existing parameters. So the key points is that the API endpoint, you need to find it within your Kubernetes cluster information. And of course, for the certificate, there is the command. You will be able to find it on our public documentation, how to write that command to get the certificate requirements. And once you're done with that, you just click on create. So let's give it some time while it creates. So for now, we can see the instance has been provisioned. You can be able to see some information about this instance. So for example, we are able to see what's the IPv4 address. You can also be the private IP, sorry. You can also be able to verify the information about the subnet, and also the image that we've used. And in case we had any issues, we would have been able to see it, the work request logs. So now, usually you should give the instance a couple of minutes, maybe 1 or 2 minutes before you're able to see it within your cluster. So for example, if now we write kubectl get nodes, we expect to see this IP, the 10.0.10.235 as part of our existing worker nodes. So let's just write that command. And as we can see, it has been added within our worker nodes. So you will realize in the first few minutes, it will show as not ready. So you usually give it another couple of minutes because everything is just setting up. And after a few seconds, or rather a few minutes, depending on the situation, it will get itself to ready status. Maybe we can even just try that again. Yeah, so now you can see it's on ready status. So if you want to get more information about this node, you can just write kubectl describe node with this IP. Sorry, just copy it directly here. Maximize this so you'll be able to see all the information about this node. And in case of any issue, so for example, if you realize that it's not getting to a ready status, you can be able to investigate further based on this command. So that's it. That's how you add a self-managed nodes. Like I mentioned, the beauty about the self-managed nodes that now you can be able to utilize any compute shape that we have. If you want to take advantage of our RDMA architecture, any of our GPU shapes that maybe are still not yet supported within OKE, this is a very simple and easy way of going about that. So without further ado, that's it from my end. Hope you've learned something, and let's meet on the next session. Thank you.